Thanks everybody for being here. I'm Sébastien Deleuze. I work for Pivotal as a Spring Framework committer. And today we are going to talk about why Spring loves Kotlin and what Spring application look like when you are using this language. Nowadays, the most popular way to build web application is using Spring Boot and Java. And we are going to see how far we can go when using Kotlin instead of Java. And we are going to do that in a progressive way, using multiple steps to transform our Spring Boot Java application to a Spring Boot plus Kotlin. At the beginning of the year, I announced the official support for Kotlin in Spring Framework 5, and we get a huge number of feedbacks, retweets, and yeah, the community seems to be excited about that. So since early of the year, we have continued to work on that, to improve the support, and to get feedback and contribution from the community. And today, I'm going to present you what is the current status, what could you use in production with the upcoming Spring Boot 2, and also the next steps, what's going behind that. So we are going to migrate a typical Spring Boot application to Kotlin. So I have created a sample project, Spring Kotlin Deep Dive, which is a blog application, a regular one, developed with Spring Boot, Java, Spring MVC. And we are going to transform it progressively to use Kotlin. After the talk, or during the talk, if you prefer, you can have a look to the source code. There is multiple branches with the multiple steps, and you can have a deeper look when you will be back. So the first step is to change only the language. We have introduced some Kotlin support, first-class Kotlin support in Spring Framework 5, but the first step will be just to use Kotlin as a language with Spring Boot 1, which does not provide any specific Kotlin support, and we are going to see what we can do with that. The second step will be to migrate to Spring Boot 2, which is based on Spring Framework 5 and provides Kotlin support out of the box. Step 3, I guess you have heard about our new WebFlux web framework, and we are going to use it to replace Spring MVC and to see what are the advantages of doing that with Kotlin. And the last step will be to use the functional API and the Kotlin DSL available in addition to the annotation-based programming model, which you already know since it is similar to Spring MVC 1. So let's start with the first step. And we are going to discover the language through various examples that you may be familiar with in Java. The easiest way to start a Spring project with Kotlin is to go to start.spring.io, and you can select the Kotlin language. You can also use directly this URL to get Kotlin already selected when you go to the page, and you can share it to your colleagues. But yeah, that's the easiest way to start a Spring Boot application with Kotlin, and you get all the Maven and Gradle plugin configured, and you get a project that works out of the box, and you can start with that, like you do with Java or Groovy. Obviously, one of the first advantages of Kotlin is to be able to write more concise code, and while it is efficient to write even Java code like that in Java because you have all IDEs that allow to do code generation very fast, and with Eclipse and IDE, you can create both Kotlin and Java code very fast. I think when the time comes to maintain your code, to read your code and maybe someone else's code, I really prefer to maintain the Kotlin version since the signal and noise ratio is much better. So yeah, it's not only about efficiency when you write code, but about maintainability of this code and being able to find bugs easily. So you can see that the Kotlin version has a few differences with Java, and obviously it's much shorter. So the syntax I'm using here is able to declare at the same time the constructor and the properties. That's similar. In Scala, I think you have the similar possibilities. We still have classes. Classes are public by default in Kotlin, so I don't have to add this keyword. Data is optional and mean that for this class, I will automatically, the compiler, not me, but the compiler will automatically generate equals, hashcode, toStrings, and other facilities. And it also puts some limit in this class. It can only contain pure data and not too much behavior. But it's an optional keyword. You can use it or not. You can see that there is this val keyword. So val is for immutable properties, and var is for mutable properties. In Kotlin, you can do both, but it's more idiomatic to use immutable classes initialized via constructor, where in Java, usually we use mutable properties with setters and getters. So here, only the getter will be available, and we initialize that via the constructor. You can see that the type is suffixed, so that's a difference in terms of syntax. We have optional parameters with default value, so if you have a look to added at property, instead of requiring to implementing an overloaded constructor with a different signature, here I'm using the same one, and I specify that if the last parameter of article is not provided, it will automatically take the now value. So again, here it allows me to have more semantic code and shorter code. You use the same annotation done in Java, that does not change. And you can see the question mark at the end of string for description. We will talk more about that later. It's for the null safety. Another super important feature of Kotlin is to be able to write emoji in your function names. No, just kidding, but I usually use this backticks trick. So backticks allow me to use real sentences with any kind of character to write my function names, and I never use that in production code, okay? But for tests, it allows me to write easily expressive function names, and when you run your test and have errors, that's super useful, I think, instead of our regular camel case thing that we do usually with tests in Java. So that's pretty useful for tests, and that comes for free. Here is a regular Spring MVC controller written in Java. So that's a typical controller. I can maybe just say that it is using implicit auto-wiring. So as of Spring Framework 4.3, when you have a single constructor, it is automatically auto-wired. You don't have to add the @auto-wired annotation on the constructor. And also, we are using here the get mapping, post mapping, etc. Aliases, which are annotation to replace request mapping plus specifying the method with an annotation attribute, so that's shorter. And also, that's also a good idea to use that by default, because usually people expect that request mapping without any method specified just match to get method, and in fact, it match to all methods. So maybe take the habit to use get mapping, which will only match get method. I think that's safer to use that. So this is Java code. And now this is the Kotlin version. So in Kotlin, I usually advise to use constructor-based injection even more than in Java, because we are going to see that Kotlin deals with null safety in its type system, and that's the best practice to do that. So here, I'm providing with the same kind of syntax. I'm defining a private property, which is user repository, which will be automatically injected by Spring because we have a single constructor. You can see that I don't specify the public keyword because the class is public by default. And member functions are defined with this fun keyword. And here we are using the short syntax. So when I have a method, a function body with a single line, I can use this short syntax with equals. And the return type of find1, find all, and save will be automatically inferred based on the repository ones. So when you come from Java, and even generally, it may be confusing so you can write the return type, it's optional. So in that case, I avoid to write that because I don't want to duplicate the information. But be aware that in ID, there is an option that is not enabled by default and allow you to to show a hint about the invert type. So that's pretty useful, even more when we are coming from the Java world, because we are not forced to write the return type, but the IDE show us the return type inferred by the language. So that's a pretty useful feature that I recommend you to enable. When we started to build Spring project with Kotlin, there was a few pain points, and one of the pain points is that we had to use open keywords in some places. One of the design decisions of Kotlin is to have classes and methods final by default, and you have to use the open keywords to make it possible to extend the class or to overload a method. And that's a design decision. Maybe not the easiest one to understand, but there is some reason for that, and it's the case now, so we have to live with that. And Spring, in some places, like for transactional management or for Java config, require to extend at runtime classes or override methods to provide you various features. And while you don't see that in Java because classes and methods are open by default, in Kotlin, you had previously to add these open keywords, which is not super natural, more verbose than Java, and clearly a pain. So we discussed with the Kotlin team, and they provided us a kotlin-spring plugin, which will automatically open classes and methods annotated by Spring annotation. In practice, that supports meta annotation. That means that even if you have some customized annotation in your company, meta annotated with add component, for example, it will be taken in account and opened by the compiler. You can obviously also specify your own annotation for that. So in practice, we set up the Kotlin Spring plugin in Maven and Gradle configuration in start.spring.io, so you don't really care about that. That will be done automatically. So we are going to switch to Spring Boot 2, which provide support out of the box for Kotlin. Until now, we were on Spring Boot 1, which does not support specifically Kotlin. Even with Spring Boot 1, that's already an advantage to use the language. So when I say that Spring loves Kotlin and officially supports it, I'm not only talking about Spring Framework 5. Spring Framework 5 provides first-class support for Kotlin, and a lot of its features are usable in the Spring ecosystem. But there is also Kotlin support in Reactor 3.1, Spring Data K, and Spring Boot 2. So we are going to talk about these various features, but really, that's not only about Spring Framework, that's also about the whole ecosystem, and I guess other projects will also provide at some point some feature when they are needed. One of the reasons why we support Kotlin is that it provides super great interoperability with the JVM, and while with other languages, it's not super easy to work with Java libraries. In Kotlin, they really did their best to provide a nice and modern language while keeping a very good compatibility when you are using Kotlin code from Java and the other way. So that's a key reason why we think Kotlin is a good fit with Spring. We provide Kotlin support out of the box. This is a screenshot of the content of the Spring Framework 5 jar. And we do not provide some kind of spring-kotlin.jar extension. The Kotlin specific bytecode is directly provided in the regular Spring Framework, Spring Boot, Spring Data K jar. And when you are using Java, they are basically not used. And where you are using Kotlin, the Kotlin features are available out of the box. So, and Kotlin API is basically the Java APIs plus various extensions and API that I'm going to present you today. We provide a comprehensive documentation, so both reference and API documentation. Feel free to go to this link. It's in the language support section. And what I'm going to present you today is described in the reference documentation, and we continue to update it. In step 1, we were running SpringOne application with Kotlin with this kind of code that is automatically generated by start.spring.io. So we have a main method, and we run Spring application.run specifying the class. So since we are in Kotlin world, I'm using the semicolon class.java to get the Java class, because application semicolon class return a K class, which is Kotlin class. So it's okay, but it's not super idiomatic. So in Spring Boot 2, we provide a top-level function which is run application, which is specific to Kotlin, and which allow you to just specify the application class, and that's it. So better looking syntax. You can obviously define additional bins like you do in Java, and you can here take advantage about the type inference, so the syntax is shorter. And you can also, so it is not just about basic syntax sugar for simple use case. You can customize Spring application by adding a lambda, and here you can customize every kind of property about the Spring application. I don't think a lot of people set the banner mode off, but that's an example. I'm going to present you now two features that we are providing through Kotlin extensions. So Kotlin extensions are a way to add methods to existing types, even if you don't define these types. So in practice, you can add methods to string, to any kind of Java class from the JDK or for Spring. It may sound a little bit too dynamic for a language that claims to be as statically typed as Java. But in fact, extensions are like static imports. You need to import them to be able to use them, and I tend to think that's a reasonable trade-off. It's a replacement for static methods, basically. When you have your utils classes with static methods, in Kotlin world, you avoid this kind of thing, and you directly add the function on the type where it belongs more naturally. So the first Kotlin extension I would like to show you is just a basic syntax sugar, but that's just to show you the power of the system. So we have this model class, which is Spring MVC1, and we define in Spring Framework jar this extension. So I'm specifying that I'm adding the set operator, I'm defining the set operator in model class, and when I will call the set operator, I will just call this.set attribute, so this is the model, model.add attribute with the attribute name and attribute value. So in Java, I'm writing model.add attribute, as usual. In Kotlin, I will be able to use this short array-like syntax, which is bring by the set operator, and both will be equivalent. A more useful one, and one that go beyond just syntactic sugar, is leveraging the Reified type parameter. So Reified type parameter is a strange name, but basically it allows to avoid type erasure that make it not possible to get the class from a generic type in Java. And Kotlin provide in some cases a way to avoid that. And we leverage that via various extensions. So basically, in Spring API, when you provide a class, we try to provide you this kind of extension because that solves a lot of issues. For example, I don't know if you have ever tried to get a list with REST template, but that may be one of the most famous Stack Overflow issues. It's not super obvious how to do that because when we just specify the class, we lose the inner generic types. And while in Java, we have to use parameterized type reference if we want to get that serialized, especially when using Jackson, JSON views, and things like that. In Kotlin, I have just to, we have added an extension that it basically, it is able to get the class from a generic type. You see that I define a Reified T, a generic parameter, and in the code, I am able to reuse it and pass it to parameterized type reference underneath. So in practice, the code in Kotlin is much shorter. Here I am taking advantage about also the optional parameter with the default null value. And yeah, the code is just shorter, and you don't have to repeat any information that the system type has already. Okay, now null safety is one of the most interesting Kotlin features. Before working on Kotlin, I was not super convinced about the importance of that topic. Obviously, null pointer exception has always been an issue, but yeah, in Java, I'm used to deal with that. I try to specify this information in the Java doc, and so let's compare how Java and Kotlin deal with that. In Java, nothing is enforced as a type system. So while a value could take a null value, we don't have any information in the type system to know if that will be the case or not. Yes, there is no check at compile time. Null pointer exception could arise at runtime, but we don't really know when. Okay. And optional, which is, because null is in a lot of places used to specify this can take a value or not. Okay. So we have the optional type in Java 8, but optional has some limitation, and in practice, it is only usable in return values. It's not suitable for fields for performance reasons. It's not suitable for input parameters, because that's a nightmare in terms of syntax. So yeah, for some return values, it's usable, but that's not the universal answer for this, there is a value or not. In Kotlin, null safety is managed in the type system. The default is non-null, so if you have a type foo, it will be non-nullable, and if you have foo question mark, it will be nullable. There is full check at compile time. That means that you don't have any null pointer exception. Everything is checked at runtime, and you can't have a null pointer exception at runtime, which is a big improvement. And there is functional construct on nullable values. So even if in Kotlin we usually don't use optional, we have some functional constructs like dot, question mark, Elvis operator, and other things that allow us to deal with nullable values like if there was some kind of wrapper around that. So that's a zero-cost abstraction to deal with that, and that's why in Kotlin usually we just use nullable values. Some people prefer to do full functional code, but usually we just deal with null safety like that. The issue here for us at Spring is that the whole Spring Framework API is developed in Java, and Java does not provide any information about the null safety. So when you are creating your nice Kotlin project with type safety everywhere in your code, when you are calling Spring Framework API, you basically don't really know, and Kotlin can't know if this parameter or this return value could be null or not. So by default, Kotlin interprets these types are platform types, which means unknown nullability. That's exclamation mark. Kotlin is not able to know if this will be null or not. And in practice, it is quite lenient when you write code, so it don't bother you too much. But when you run your code, you can still have null pointer exception, and it defeats the purpose. So what we did, and I think that one of the features that took the most time to Jürgen and me to do, is to add null safety annotation in the whole Spring Framework API. The journey is not finished yet, but we are close. So the principle is that Spring Framework 5 provides null safety API at non-null API, which defines the default at package level, and it says every non-annotated parameter or return value is considered as non-nullable. So non-nullable is the default. It's similar to the default behavior in Kotlin. And when we have a specific return value or a specific parameter that could be nullable, we specify that with the at nullable annotation. And we have done this work in the whole Spring Framework API and also in Spring Data K. In Spring Boot, not yet, but that may be the case later. And the nice point is that when you are using the -x GSR 305 equals strict compiler argument in Kotlin, basically, Kotlin will infer the null safety of the parameter and the return value based on this information. So with this, with Spring Framework 5 and Spring Boot 2 and this compiler argument, which is enabled by default, no, not enabled by default, you have to set that, you will get a full null safe API for Spring Framework, Spring Data K, and later for Spring Boot. So I think that's a pretty important feature. Notice that our, so at non-null API, at nullable are Spring annotation that are meta-annotated with GSR 305. which is a kind of strange beast. It's a dormant GSR, but widely used in the ecosystem. I hope at some point there will be a more first-class option to be able to define that. But currently, the trade-off we have is Spring Framework define its own annotation because we don't want to use directly a dormant GSR, and we meta-annotate it with GSR 305 annotation for generic tooling support. Another places where we leverage Kotlin nullable information is for @request param and @auto-wired required attributes. In Java, you have to set a required equal false manually if you want that. But in Kotlin, if you are annotating nullable types, that will mean automatically required equal false. So in practice, here we have a full controller. You remember it's the @auto-wired is implied. Okay, it is not here, but is implied. And Kotlin will, Spring Kotlin support will analyze the null safety of the type. So in that case, foo bin will be mandatory. Okay, if there is no foo bin, an error will be raised. And bar is nullable, so required is set to false by default. And if there is no bar bin, a null value will be injected. The same is available for @request param. @request param on a nullable string, for example, means that this parameter is optional. Okay, now one of the remaining pain points, sorry for that, but it's not yet fixed. So configuration properties in Spring Boot are a super nice way to deal with type-safe properties, and much better in my opinion than @value. But it's basically designed to work with mutable classes that don't care about null safety. And in Kotlin, null safety does not play very well with setters and getters that are not defined via constructor, because basically when the class is initialized, you have null in that, and after it is initialized. So there is late init var, there is various things to deal with that, but concretely, currently, you have to use nullable, you have to use nullable values and mutable properties. We are going to see later that we are working to fix that, but currently that's a requirement. Back on the test. So in addition to the backticks, we have other nice feature. Spring Boot 2 and Spring Framework 5 support JUnit 5 by default. So it is not used by default in Spring Boot 2, but you can use it by modifying the dependencies, and it is supported. And one of the nice features of JUnit 5 is the per class lifecycle. So by default, and with JUnit 4, this is the only option available, your class, your test class, is instantiated for each test, okay? And your @before class in JUnit 4 and @after class need to be static. And static is not a very good fit with Kotlin because it does not directly support static methods. It provides some companion object, which is possible to use, but not super idiomatic in terms of syntax. So what I usually do in Kotlin is that I enable this per class lifecycle for my whole project by defining a property in JUnit-platform.properties. And with that mode, my test classes are instantiated just one time per test classes, okay? And it enables to have non-static before all and after all methods, which are the equivalent of before class and after class from JUnit 4. So in practice, I just have to annotate regular methods like I do with testng, for example, which provides this possibility. And that's a very good fit with Kotlin. Another super nice JUnit 5 support feature is constructor by injection. Like I said, constructor injection is a very good fit with Kotlin because of the immutable null safety focus. And with JUnit 5, and that works also for Java, so feel free to use that also for Java, you can auto-wire parameters. So that's a little bit different than in the regular code. You have to annotate the parameter, your constructor parameter, and it will be automatically injected by Spring. That's a super good fit with Kotlin as well. And you can use all these features together, for example, to write specification-like tests. There is some Kotlin-specific framework like Spec, for example. It's, the integration with Spring is not that great, and I don't really like the fact that you can't inherit from a common class. So even if you want to write specification-like test, you can use JUnit 5 and Kotlin to use the nested feature from JUnit 5. You can use the display name at the class level. For the function, you just have to write the backticks, and that way you can write very nice-looking specification-like test with just plain Kotlin, JUnit 5, and Spring integration. OK, step 3. Now we are going to switch to WebFlux. So Spring Framework 5 introduced a new web stack, which is Spring WebFlux. I guess you have heard about that in previous talks. It provides a non-blocking runtime based on reactive streams. So concretely, it's allowed to have a better scalability when you have a lot of concurrent requests that will require a thread for each one of them. It's allowed to deal with latency very easily, and also it's a good fit for streaming. So in addition to our Spring MVC servlet-based stack, we provide a new reactive stack which provides new capabilities. For example, it makes it possible to run on Netty and Otherto without using any servlet things, API. It provides a reactive client, which is also usable with Spring MVC 5. And it provides, in addition to the regular controller annotation-based programming model that you know, a functional endpoint, which is available in both in Java and Kotlin. And I will show you later why I tend to think that in Kotlin, that's a very good fit. So the internals of WebFlux is based on reactive streams and implemented with Reactor, because reactive streams is just a kind of SPI you need to use an implementation that's just for interop and defining the behavior. And WebFlux supports various non-blocking APIs. So we support completable feature, Flow Publisher, which is reactive streams baked into Java 9, Eric Java 1, Eric Java 2, and Reactor. So these libraries are supported out of the box. That means that, for example, if you return a completable feature, or if you return an observable or flowable in Spring WebFlux annotation-based flavor, it will be supported by default if you have these libraries in the class path. But reactive streams also support other libraries. For example, Aka is based on reactive streams internal and has a good reactive streams interoperability. That means we can easily use Aka types using the reactive streams for the interoperability. For now, we are going to focus on Reactor, and we will see other kind of reactive API later. So Reactor provides two main reactive types, mono, which is a kind of a reactive type for 0 to 1 element. So you can see like a reactive completable feature. And it provides operators suitable for dealing with just one element. Flux is for reactive collection and streams, and it provides even more operators. It's similar to Eric Java observable or flowable types. And both types are natively based on reactive streams. That means that both Mono and Flux implements a publisher interface. So what looks like Spring WebFlux with annotation? So it's similar to Spring MVC version that we have seen previously, except that here we are using reactive types. So here I'm using Flux and Mono. Again, you can use completable feature, you can use observable. That's up to the library and the ecosystem that you are using. But a very important point is that you can't use blocking types. You can, but the performance will be not that great. So we provide, in Spring Data K, we provide reactive support for MongoDB, Redis, Cassandra, and Couchbase. We usually get the question about SQL, GPA, and things like that. So there is an async JDBC initiative from Oracle. The current stage is that we are currently discussing, providing feedbacks. I guess they have an internal drivers for Oracle and MySQL, but yeah, it's coming. At least we are discussing about that, but it's not yet available. So currently, the reactive persistence database are NoSQL, and SQL database will come maybe later. So this is, you are using reactive types. In addition to just the return types, because my example is super simple, the key point to understand is that reactive API imply functional programming. So instead of doing imperative programming like you do usually, you switch to the functional API, the functional programming, which is much powerful for this kind of syntax, but it implies a different way of developing your application. In this example, fetch weather is a method that returns mono of weather. So that's something that will return weather at some point. It's basically event-based. And the way I'm using this API is I'm calling main service.fetchWeather, that's usual, but instead of just doing that, I'm using some dot notation. So it's a kind of fluent API where I define that if there is no answer after 2 seconds, I raise an error. Then I define that when there is an error, I print the message with the logger. And in case of error, I want to call a backup service, which is maybe a service with outdated data, but that run locally and that will be reachable. And if there is an error, I use the backup service instead of the regular one, and the consumer service won't see any kind of difference. So it's to do some kind of failure management. The map operation is to transform the weather object into some string. Here you can see that we are using Kotlin string interpolation. Okay, you don't have to write plus with various strings like in Java. And in addition to be more readable, it's also perform better because you don't have to create various strings. And the last step is subscribe because until map we have just defined the operation, but nothing concretely is processed. And subscribe is for triggering the processing, basically. When you are developing WebFlux application, usually the subscribe part is done by the framework. You don't have to care when to run this processing. It's, for example, raised when you receive a request or a thing like that. So I said previously that Reactor provides Kotlin support. So at the left, you can see that there is a Java version when, for example, to create a string, a mono from a string, we write mono.just foo. That's similar to what you have in reactive extensions world. And in Kotlin, you can just write it like in Java, but you can also write it with an extension. So there is a toMono extension that applies to object that allow to transform any kind of object to a mono with this kind of syntax. We have the same for Flux. So in Reactor, there is some methods to transform an iterable to a Flux. And we use this flux.fromIterable static method. In Kotlin, with the extension that we provide, you can write a list.toFlux, and it's maybe more nice looking and more readable. And a limitation of the fluent APIs, like Reactive APIs in Java, is that you can't add a type, you can't add a method or an operator. I mean, for example, Flux is final, and you can't add new methods. So with extensions, we can, for example, add an average operator right to the Flux type, like if it was supported natively, even if in practice it's provided by a Reactor add-ons, which is a different jar. So again, that's just syntaxic sugar, but that provides a better alternative to utilities method. Okay, now the last step, and after we will see what are the next step. So we are going to leverage Kotlin DSL and functional API because, like I said, WebFlux provides two programming models. So basically, the same annotation-based programming model that Spring MVC, because a lot of people already know Spring MVC, and we want to be comfortable with that. And basically, we provide the same capabilities in both WebFlux and Spring MVC. But you have seen that using a Reactive API implies switching to a more functional style of programming. So we thought that maybe that would be also a good idea to provide a functional programming model, which has been asked by many for many time. And we provide that in Java. I don't know if you have seen Ariel Putzma, very nice talk about that, but it is available in Java, and all the features are available in Java. But I do think the API is much nicer in Kotlin. So on top of this Java functional API, we provide a DSL. So a DSL is a kind of more high-level API that allow you to provide in a more declarative way various things. So we don't want to abuse to DSL. So in Spring Framework 5, we provide two DSL, the router one and another one that we are going to see later. And this DSL allow you to declare with Kotlin code. So this is regular Kotlin code, but a kind of declarative Kotlin code. It allows you to define various routes. So instead of using @request mapping annotations, which are spread across all the controllers, here we are defining in a more centralized way, but you can use 1, 2, 3, 10 routers. That's up to you. You control the granularity of the routers. And you define various routes using request predicates. So an example of request predicates is, for example, every path that is /API/user, that's a path predicate. And in the Kotlin DSL, I just have to specify it with a string. I can also use request predicates based on the media type. So for example, accept application JSON will match every request that accepts JSON for web services, for example. And you can combine them with AND or a not operator. I must specify that AND is just a regular function. You can see that it is just, you may think it's a keyword. It's not a Kotlin keyword. It's an infix function. So infix functions are regular functions that are, I have just added the keyword infix, and that means you can call it without parentheses, okay? So that's not suitable for every usage, but in that case, where we want to provide basically a sentence that you can read easily, and could be used with parentheses or without, and here we are using the version without. So you can combine any kind of request predicates, and you can even create your own request predicates, okay? We provide several ones, but you can create yours. You can see that we can nest request predicates. So if you have a look to accept text HTML, that's a common request predicate that will apply to all the nested ones. So here is basically an equivalent of /and accept text HTML and /SSE and accept text HTML. So you can nest request predicates with any number of levels, and that allows you to write quite complex mapping logic in a more readable way. In that example, I'm directly providing the handlers implementation. So we have really two parts in this kind of application. We have the routing logic, which just defines which handler will be called. And then we have the handler implementation, which is basically the equivalent of our request method implementation. Here, that's a simple example, and I have directly put the handler implementation in line. And when a specific request predicate will match, we will call, for example, OK.render index. Views are supported, server-sent events, regular REST web services. You have these various possibilities. Now, how that integrate with Spring Boot, okay? So in real applications, I tend to think you will use distinct classes for your routers and your handlers. So what I usually do in this kind of application is that handlers are injected, okay? So here I declare a router. I just inject HTML handler, user handler, article handler, and then I use the same syntax for the router that I showed previously, but instead of directly putting the handler implementation inside the router, I'm just using method references to point to the handler to be called. And that's a nice separation between the routing logic and what will happen when a request will be called. Concretely, the handler implementation is like that. So that's a class with our usual constructor injection-based pattern. And each method is a method that takes a server request and return a mono of server response. So that's a different model than Spring MVC, when you can use some fancy parameters and automatically the framework will inject these values. Here we are more in control. We provide a more functional, fluent style of API, and you can basically do exactly the same thing, but yeah, that's a different way, a different programming model. So, until now, we have seen the features that are really production ready. When I say production ready, maybe you want to wait Spring Boot 2 to be released, and I know a lot of you are waiting that, and it's coming, beginning of next year. But right now, with M7, we have a quite good level and of support, and yeah, things are quite stable, and already some people are in production with that. So I think it's usable, but really everything I have shown here is production ready in the same way that the Java support is. Now we are going to talk about what's next. And we are going to talk about 4 points. The first one is fixing the remaining pain points, because we really need to fix that. So for configuration properties, in order to fix the current pain points, the idea would be to support immutable classes and data classes with non-nullable properties. So there is an issue. You can have a look to this one to see why it's not that easy. Okay, so we are working on that. I'm not sure yet it will be part of Spring Boot 2.0. I will try, but not sure yet. But we really want to provide a better experience, so yeah, we are working on that, and we will provide that as soon as we can. The other main pain point is web test client. So web test client is basically Spring WebFlux mock MVC alternative, but it's also much more than that. That's a pretty nice testing facilities for testing your REST APIs with mock or directly by requesting a real server. And for some reason and some limitation of Kotlin regarding to type inference, it is not usable with Kotlin. You can use some basic functionalities, but you have some type inference, and that's an issue. So we can't really do something on our side, so it's something that Kotlin team need to fix, and they plan to fix that in Kotlin 1.3. It was expected to be fixed in Kotlin 1.2, so I hope it will not be postponed, but so yeah, really, it's need to be fixed on Kotlin, and we will really push to get that fixed as soon as possible. For now, I advise you to use web client, which is a more general purpose web client in Kotlin, or use a web test client in Java for your tests. We have very few pain points like that, but that's an issue. Now, coroutines. So you have seen a lot of talk showing you WebFlux, and you have seen that it's not a free lunch. You have to learn to use functional APIs, and that's quite different to imperative programming, and that's come for a reason, because we have access to a wide range of operators to deal with latency, to change the behavior, and that's a very powerful tool, but it requires to change the way you develop application. And something interesting with Kotlin is that it provides support for coroutines, which is a little bit similar to async await in .NET, if you already know that. So basically, that's a way to deal with non-blocking and asynchronous API in a more imperative way. The difference with .NET is that in Kotlin, there is a very few things in the language part, so there is just a suspend keyword, and everything else is on the library side. That means they could easily adapt to other APIs, and that's one of the reasons there is a coroutine Reactive API interoperability. So what is the current status of using coroutine with Spring? So just to say, coroutine are Kotlin lightweight thread. That means you can create 100,000 coroutines, and it won't consume a lot of memory, like if you do that with threads. So that's really a programming model that scales very well when you have to handle a lot of things with latency, like Reactive APIs. To me, the most interesting use case is allowing to write non-blocking imperative code, okay? But that's not magic. That's less powerful than Reactive API. I mean, the back pressure and the performance has some limitation. It's maybe well suited when you deal with async values. So for example, if you deal with completable future or with mono, that's a good fit. We are going to show an example just later. But if you deal really with streaming and various advanced operator, in that world, imperative code will be not that simple. And I tend to think that even if at the beginning, when you know imperative code, you may think that functional code is hard to learn. when you do advanced thing with non-blocking codes, basically that's also a good advantage. So yeah, not magic, but interesting for some use case. Kotlin Coroutines, which is the library part of the coroutines, natively support reactive streams and Reactor. And somebody from the community, Konrad Kavinsky, has developed a very nice Spring Kotlin coroutine support, which basically brings Spring WebFlux coroutine support in Spring WebFlux. That's experimental. We are still making that evolving, so I will not use that in production for now. That's why it is noted experimental and is in the under construction part, but that's interesting. We are evaluating if that will make sense to integrate an official support for coroutine in Spring. So I guess you will have more news next year. So that's currently under evaluation. To show you more concretely what that means, here is a table with coroutine reactive interoperability. So in reactive world, when you have a mono, it will translate. So if you have a function that returns a mono, that will translate to a suspendable function. So suspend is this coroutine keyword. Suspendable function that just returns T. Okay? So you don't have to use any wrapper. And you can use the same for mono of list, which is basically a collected list. You can just return lists like you do in blocking world with this suspend keyword. And for these use cases, I tend to think that's a pretty good fit if you don't care about some limitation. For example, here, you will have to wait that all the elements of the list has been retrieved before beginning processing it. You will use more memory, maybe there will be more latency, but that's a trade-off. You can keep an imperative programming style with some limitation. Coroutine also provides a dedicated type for streams, which is a receive channel. So instead of using a function that will return a flux, you will use a suspendable function that returns a receive channel. And here, I'm a little bit less convinced about the interest when you use a lot of streaming, because basically it's a new type that you have to learn, like reactive APIs. And I'm not sure for stream scenario, I'm not sure about interest to use imperative programming. So we are currently experimenting on that. Feel free to experiment also, but I think that's where I would draw the line. And for just async completion, which is expressed by a function that returns mono of void in WebFlux world, we are just using suspendable function that return foo, and that's it. So I have created a branch in my Spring Kotlin deep dive example, which is based on coroutine, so that works. We have even done benchmarks, and we get quite good performance, less than reactive APIs, but that's close, not much impact. And that's because here I'm not using coroutine everywhere. I tend to think that the good performance is also because I'm using reactive APIs in all the internals, and just for the user-facing part, your code, we are just translating mono to coroutines. And basically, that's just a different way to provide you that, but the internals are still the WebFlux ones, and via reactive streams, the interop is quite great. So in practice, this is exactly what your blocking codes look like, okay? If you have a look to the, I think, step 2 branch, it is Spring MVC and regular blocking Spring Data MongoDB. And in that code, I have just added suspend keyword, and that's all, okay? So that's where I think coroutines are interesting. It's a kind of, a trade-off. You can leverage the non-blocking runtime and all the features provided by WebFlux. But for some use cases, it's less powerful than reactive APIs. The two last topics are more for the future, so I don't say that we will do that or support that. That's just some ideas I share. I don't promise anything, but I tend to think it would be interesting to experiment on that next year. The first one is boot plus functional bin DSL. One thing I have not talked about yet is that, and this is production ready, Spring Framework 5 introduced a new functional bin definition capabilities, which is very efficient, no reflection, no CGLib proxy. It's basically a new way, in addition to XML and Java config, to define your bins, okay? It's using lambdas instead of annotation, and like the router DSL, it is both declarative and programmatic. So this is something that is already supported in Spring Framework 5. You can define your bins like that. So you remember we had our routers, our router DSL. Now we have a bins DSL, which is a kind of trade-off between Java config and XML. We have a kind of declarative thing, but it is still a code, a Kotlin code. So here I'm declaring a bin specifying the class. Notice that this bin will be automatically auto-wired if there is a need to do that. So when I specify a bin of article repository, if article repository have some constructor or field-based injection, they will be automatically injected. We can use some more dynamic statement like environment of profiles to be able to do conditional registration. So this is facilities that we provide by default. But you can use also any kind of if statement, if customized statement. This is code. So you can use for loops, you can use if statement, you can use what you want. Router and bins DSL fit quite well together. So in that example, I'm declaring some bins. So the router DSL, in fact, declare a router function bins. So if I'm combining both bin and router DSL, you can see that I can easily declare a router. I can also support references to another bin. So for that, I'm using this ref with the type syntax. In fact, this one there is no magic. This is just an alias for application.getBin user handler semicolon class.java. That's just a shortcut to the application, and this will be executed. This is our all lambdas that will be executed when the Spring dependency injection algorithm will call. You can also provide yourself the implementation, like with the mustache bin. And so this is a POC, a proof of context done by somebody from the community, so nothing related to us. But I think it showed an interesting thing. This bin DSL is extensible and composable. So somebody has created a DSL that allows to run a standalone WebFlux application. So in this case, we don't use boot. And he extends the bins DSL to provide some kind of a DSL for defining your application, specifying what kind of runtime, and defining more high-level construct than just bins. For example, here, mustache templates will internally return bins of, etc., and you can register single or multiple bins. So it's just to show you that that's maybe a building block that we could use in the future or not, not sure yet. So back today, functional bin definition with boot, you can use, you remember the lambda on run applications because this bins DSL is just using a building block that we have for a very long time in Spring Framework, which is an application context initializer. And so I'm just specifying that the database context and the web context, which are defined here and here, are just regular application context initializer. In practice, this nice syntax only works for application, not for tests. So if you want to use that for tests, I advise you to create a context initializer bin like that and specify it into the application .properties. I have put that in the under construction part because I don't think it's usable for now in Spring Boot, because in practice, for example, if you use Spring Data, you will need to have all the configuration thing imported, and I don't think that's ready for a wide usage in Spring Boot, but maybe in the future we can maybe provide a more functional way of specifying things, and I'm not sure it makes sense in Java, but in Kotlin maybe, we will see. So feel free to provide your feedbacks and ideas on this issue when we discuss that. That's not for Spring Boot 2, that maybe will never be supported, I'm not sure, but I think that's interesting to discuss and see how far we can go with this kind of approach, especially if Kotlin usage in Spring Boot gains some market share. And the last topic is even more silly. That's multi-platform support. So Kotlin has a first-class support for the JVM, and that's very, very nice. And they still provide, and they will continue to provide first-class support for the JVM, and for Android. because Google announced official support for Kotlin, and that's why of the reason I truly believe that the Kotlin market share will increase. Some projections seems to think that at the end of next year, half of the Android developer will use Kotlin. Maybe that will be not the case, but what we can say is that the number of Kotlin developers, Android developers, is quickly increasing. Kotlin support also compiling to JavaScript and native. Clearly, this has not the same level than the JVM support, so that's still experimental from my point of view, especially the native support. But that's interesting to notice that Kotlin is not only for the JVM, and it is already possible today to write your Kotlin your front end with Kotlin JS. So if we take this example, this is regular JavaScript code that is using the notification browser API to show you a little notification, hey, there is a new blog post. You can write it into Kotlin. You will gain all the nice features from the language, so null safety, type safety, some things that, the Kotlin syntax look like a little bit like TypeScript. Honestly, the interoperability between Kotlin and JavaScript, we can do a lot of things, but it is clearly not as easy as with TypeScript, because TypeScript is a superset of JavaScript, and things are less smooth with Kotlin for sure. Until a few months ago, it was generating a huge amount of JavaScript. Now there is a dead code elimination tool which provides a reasonable amount of JavaScript generated. So you have only 10 kilobytes of JavaScript generated for this example. So I'm not sure on the long term the Kotlin JS will catch up against, for example, TypeScript, which is natively based on JavaScript. So my bet is on even more ambitious option, which is WebAssembly. So WebAssembly is a native platform for the browser. It is already supported by the 4 major browsers. So the browser that you have in your laptop and in your smartphone already support WebAssembly. That's not something that will maybe happen. It is already the case. This has some limitation because you don't have access with WebAssembly to the DOM API, for example, and there is no garbage collector. But this is a standard pushed by the W3C. The big players are working on that. There is no plugin involved. And that's a little bit the continuation of the story of ACMJS, Dart, native client, and other kind of JavaScript alternative. So an option is to compile Kotlin to WebAssembly because it has been announced 1 month ago at KotlinConf. So Kotlin Native 0.4 supports already compiling Kotlin code to WebAssembly. Honestly, that's the very beginning. It's super alpha. It's breaks, okay? But it begins to be supported. And I believe that that's a better compilation target than JavaScript because that's a true bytecode, okay? JavaScript is used as a web bytecode, but honestly, that's not designed for that. It is binary. It has good level of performance of memory. I see a lot of people complaining about the amount of memory consumed by Slack and other web-based API, but using this kind of technology, it could make it much more efficient. And currently, you have to pass through JavaScript to be able to call DOM API, but native DOM support and GC are coming. I'm not sure when. That will be maybe in 1 year, in 2 years, but for the long term, I truly believe in that because that could make it possible to create a Kotlin native front-end ecosystem that will not replace JavaScript. I'm not talking about that, but that could be in parallel of the JavaScript ecosystem, a more native ecosystem with Kotlin, Swift, Rust, and other languages like that use that as a compilation target instead of generating crappy JavaScript code. Kotlin 1.2 allows sharing code between platforms, so that's also something that we may or may not support. But Kotlin team is working on multi-platform data types, for example, multi-platform dat and time types that would allow you to share the same domain model between JS, native, mobile, and server. The related libraries for serialization are also coming, so we will see. That's super early, but that could be something that we could support on the JVM side as a serialization technology, like we support Jackson, for example. We will see if that makes sense or not. Thanks for your attention. You can find the slide on speaker deck, and I'm available if you have any question. Thanks.